Hello folks, we are once again back with the miscellaneous exercise problem number 17, which reads that show that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius capital R is 2R over root 3. And and also find the maximum volume. So it's a volume. Again, we go back like this, that it's going to be pi R squared H, two variables. We have to get it in terms of 1 and so on. So that's going to be our work. So let's get across right away. They have told us that it's a sphere of radius capital R in which this cylinder is lying. So the cylinder's height h and radius r is what we are assuming, and then we have to get the maximum volume as we have been doing all our earlier problems. So let's write, let r comma h be the radius and height of the cylinder, of the required cylinder. Okay. Now, as I have already hinted to you that R and H is going to be a problem, we require a single variable. So obviously we have to replace one in terms of the other. So we are going to check what is going to be a constant quantity that is going to help us to do this substitution. When we look over here in this figure, if you look at the triangle ABC, it's a right triangle. So that will help us to diffuse this problem. So let's check. In right triangle ABC, we have AB squared plus BC squared becoming AC squared. Why? It comes by Pythagoras theorem. So what happens? So in fact we get H squared plus R plus R. Please be careful about this. R plus R, it's 2R the whole squared, and here also R plus R, 2 capital R the whole squared. So pi r squared h, it's better we substitute this r squared. That's better. It will make the work simpler. Then in that case, this will be 4r squared equal to 4r squared minus h squared, or rather r squared can become 4r squared minus h squared over 4. Now why we did this, it's very clear to us, because we wanted to do the substitution. Our target is on the volume. We know that it's a volume that we need to find. So therefore volume V, because we need to find that, volume V is going to be pi r squared h, where r squared we have the ready-made value. So let's try to substitute that. It is 4r squared over 4 minus h squared over 4. Anyways, so when you open up this bracket, it's going to be pi, 4 and 4 will cancel, r squared h first term, second term pi over 4 h cube. So we are ready. Single variable h. First derivative, second derivative, and so on. So let's go for the first derivative. First derivative is pi r squared and pi over 4 3h squared. So also the second derivative, because we have to show maximum volume. This is a constant, so no derivative. Let's take this, minus 3 pi over 4 times 2h. Of course, that also can be, it's negative, so that's very apparent that it's going to be maximum. So now for the critical point, let dv over dh be equal to 0. So what is it happening? Pi r squared minus pi over 4 3h squared equal to 0, or rather you can have 3 pi h squared over 4 equal to pi r squared. Let's right away cancel the pi, and h squared can become 4r squared over 3, or when we take the root, h can become root of 4r squared by 3, so that is 2r over root 3. That's exactly what they have asked us to show. If you look at the question, now they tell us that show that the height is 2r over root 3. This is how we get it. Now, having got this, they have asked us to show the maximum volume and find the volume also. So for maximum volume, we have to catch hold of this. D squared V over d h square at h equal to 2r over root 3. We are not actually bothered because it's a negative quantity, we know. Minus 3 pi over 2 when we simplify that, and h is 2r over root 3. Anyhow, is a negative quantity, therefore maximum occurs. And then let's find the maximum volume. Therefore, the maximum volume. What have we got it? We have got it as pi r squared h. So, pi r squared h for us. We can use this. H is 2r over root 3 and this is going to be pi over 4 h cube. So 2r over root 3, 2r over root 3, another 2r over root 3. So let's find this out. It is 2 pi r cube over root 3, first value. And the second, did I write the correct thing? Yes. Okay. Then minus 3 and 3. That's root 3 and root 3. That's going to be 3. So, and this 2 will cancel with the 4. So, we are left with 2 pi r cube. And in the denominator, we have got 3 root 3. I hope we have taken care of everything. Yeah. So in order to equalize, let's multiply this by 3. So that becomes 6 pi r cube minus 2 pi r cube, which is going to be 4 pi r cube over 3 root 3. Now let me also catch hold of the unit. Have they anywhere mentioned the unit? Nowhere. So let's call this as cubic units. That's about it. That the volume is 4 pi r cube over 3 root 3. So that's the volume of this particular thing. Pretty easy once you know this. If you are able to catch hold of this relation, then it is very free flowing. Obviously, volumes are easier, surface areas are difficult. So that's fine. So this is what we have to take care of. That's all for this video. With the next problem, let's meet in the next video. Thank you.